Welcome to Lesson 2. Here we'll learn about compound interest. So now compound interest is interest that is earned on the original investment plus the interest that's earned during previous calculation periods. Now if we compare that to the simple interest definition, that was just interest that is earned on the original investment. Now the formula to calculate the future value of the investment is FV equals P times 1 plus R to the power of T. FV is the future value, P is the principal or the initial amount of the investment, just like in simple interest. But R and T are different. R is the annual interest rate, expressed as a decimal, divided by the number of compounding periods. And T is the number of compounding periods, not the number of years. Now the different compounding periods we'll look at in this section are quarterly, which means interest is applied to the investment 4 times a year. Semi-annually means 2 times a year interest is applied. Monthly means 12 times a year interest is applied. And daily means 365 times a year. And annually means just once a year. So example 1. Lauren is trying to determine which option is better. Investing $1,000 at a 5% simple interest rate for 3 years, or investing $1,000 at a 5% compounded annually interest rate for 3 years. We're going to complete the chart to determine which option is better for Lauren. Now option 1 is already completed because we had previously looked at investing $1,000 at a 5% interest rate. So I just copied over the information. We said that after 1 year, you would earn $50 in interest, which means you would have $1,050 in total. After 2 years, you would have $1,100, and after 3 years, $1,150. Now let's look at option 2, in which the investment is compounded annually. So here we have the formula. And I see they replaced P with 1,000 and R with 0.05. Now let's look at that value for a second. To find the R value, we change our percent to a decimal, but then we have to divide by the compounding period. Interest is applied annually, which just means once a year. So we need to divide this by 1. And when I do that, I simply get 0.05. So that's where that came from. Let's look at the T value, which is 1. That's not because it's 1 year. That's because interest was applied only once during that 1 year. And when I work it out, we get the same answer as option 1. So let's look at year 2 to see if we get 1,100. So I'll replace P with 1,000. The R value is still the same. And now this time T is 2. We're getting interest just once a year. So over the course of 2 years, interest is applied twice. So that's why it's 2. Now when we put this in the calculator, we got to be careful and follow our order of operations. So we'll start with the brackets. We'll add 1 and 0.05 together first. Then we'll raise it to the power of 2 using our exponent button. And then we'll multiply by 1,000. And when you try that, you should get $1,102.50. So slightly higher than option 1. Now for 3 years, we'll get 1,000. 1 plus 0.05. This time would be to the power of 3. I'm getting interest just once a year. Over the course of 3 years, it's applied 3 times. So again, being careful with the way you enter this in the calculator and you follow your order operations, you should get $1,157.63. So in terms of which option is better, if you invest for only 1 year, it actually doesn't matter because you get the same amount, but 2 years or more, option 2 is better. you get more interest. So we'll say that option 2 earns more money. Now for example 2, if $2,000 is invested at 6% compounded monthly, what is the future value in 4 years? So let's fill in P to be 2,000. Now I'll go to the side to calculate my R value. So we'll change the percent to a decimal. Now I'm going to divide that by 12 because the interest is compounded monthly, which means 12 times a year. So when I divide that, I get that R is 0.005. Plug that in the formula. Now let's look at T. T is the number of compounding periods. So I'm getting interest 12 times a year. So over the course of 4 years, I've gotten interest 48 times. So that's the value of T. Now putting that in the calculator, you should get a value of $2,540.98. Now part B wants us to determine how much interest was earned. Well, if we take the future value that we just found and then subtract the original investment, which was $2,000, I'll get how much interest was earned, which is $540.98. Now for example 3. If $3,500 is invested at 4% per year compounded semi-annually, determine the amount of money after 3 years. I'll replace P with 3,500. Now for R, change 4% to a decimal, then divide by 2 because it's compounded semi-annually, and that means 2 times a year. When I do that, I get 0.02. Now for T, I'm going to be getting interest twice a year. So after 3 years, I would have gotten interest 6 times. So T is 6. So now putting that in the calculator, you should get $3,941.57. Now B wants us to calculate how much you get after 6 months. So 3,500 will stay the same as the R value. What's going to change here is T. Now semi-annually means you're getting interest twice a year, or essentially every 6 months. So how many times are you going to get interest after 6 months? Well, it just means once. So that works out to be $3,570.